Hello, we are the University of Houston and we're part of the Build Your Own district. Um, so a little bit about ourselves. My name is Alejandra Zamora and I'm currently studying electrical power engineering technology. And I primarily worked on the conceptual design of this project. Then we have Christy Mejia. She is also studying electrical power engineering technology and she worked on the battery storage part as well as a project proposal. Then we have Patrick Murray, who was studying EPT as well and focused on the financial analysis of this project. Then we have Laura, who worked on the construction and development plan, and she's also studying EPT, and we are all graduating this spring. So a little bit of what we're going to be talking about this presentation. First, we will talk about the project itself. Then we will talk about the conceptual design. Then we will move on to the distribution impact analysis, then the development plan, and then the financial analysis. And at the end, we will talk about the conclusion. So a little bit about the conceptual design, and it's a preliminary plan that outlines the basic components and layouts of the proposed system, which I worked on. Then the distribution impact analysis and evaluation of the potential impacts that the system could have on the electrical distribution system and that it will be connected to, and Christy will be talking about this. Then we have the development plan. A development plan for a PV system is comprehensive plan, and that outlines the steps and processes involved in the development and implementation of the system. Laura will be talking more in depth about this. And then lastly, financial analysis, which is a study that evaluates the economic viability and financial performance of the system over its time. And Patrick will be talking about this. Okay, so a little bit about our university. The University of Houston campus is located in the third ward of Houston, Texas, and it is very big. And there is always construction going on around the University of Houston. Ever since I started here at the University of Houston, there's construction, and we're going to be graduating, and there's still construction going on. There are a lot of buildings that exist across the University of Houston, and we chose the ones that are most recent or completely renovated around the campus. So a little bit about the project. The proposed plan is to utilize 6 sites using PV arrays on the University of Houston to align with the campus goal for Texas to be net carbon zero by 2050, potentially be one of the first universities in the state of Texas to build solar array structures. Our thinking of how often these buildings are used or how important they are can be to the community. The decision that we were making when we picked sites. Based on our thoughts, we chose the Fertitta Center, Student Center South, and Health Building to have solar roof arrays to assist the mass energy consumption. These 3 buildings are most of the ones that are consume the most energy. Then we have 2 parking lots and then 1 parking garage. We chose the parking garage that is the most newly built. And then the 2 parking lots are the ones that are the largest ones at the University of Houston. So now we are moving on to the conceptual design. So here are the 6 sites that we chose. First, we have the Student Center South, which is where most students congregate. And there we have all the dining options, the most of the dining options, like the Chick-fil-A, the McDonald's, the Panda. And I believe this is one of the ones that consume the most energy, because there's also big offices and where the career fairs happen. Then we have the Fertitta Center, which is where the basketball team plays. Then we have UH Health, which is the one that consumes the most energy because it has a lot of machines that consume a lot of energy. And then we have parking lot E, parking lot B, and the East parking garage. And the total system with all 6 locations will produce over 11 million kilowatt hours of energy. So the proposed design system is able to provide for 50% of the consumed energy. These PV systems will help reach UH Energy's goal of being net zero by 2050. So according to our data that we were able to get from the University of Houston, the 2017 combined energy consumption was for these buildings were 20,304,189 megawatts hour. And then the combined energy production with all the sites with the solar panels will be 11,141,390 megawatt hours. And with the rooftop installations on the Student Center, Health Building, and Fertitta Center, as well as the carports being installed in the parking lots and the garage, these systems again will be able to help the goal of being net zero by 2050. So the solar panels that we used were Astro Energy solar panels. They're monocrystalline PV modules. They have a low temperature coefficient, which improves the temperature coefficient, decreases power loss in the high temperature application. Then it has innovational 5 bus bar cells, and it reduces the cell series resistance and internal stress and decreases the risk of microcrack and improves the module output. These were positioned at a 20-degree angle, and the PV systems will be these panels were chosen because it maximized production weather protection, which is very important here in Houston because of our weather. And then as far as the rooftop installations, the design will not be compromised by the weather as we research Astro Energy panels to be able to withstand during hurricane season, which happens a lot here, and are capable of being designed to be in harsh environments. Then I will pass it on to Christy.
Okay, as for the distribution system impact analysis, I will go ahead and take that over in next slide. Yeah. Okay. So on your left, you'll see the interconnection grid on the campus site. And so who provides the energy for U of H is CenterPoint Energy, and the systems will be connected to ERCOT, the Electric Reliability Council of Texas grid. And while the system is connected to ERCOT, it will align with the National Electric Codes and the Institute of Electrical Engineers and the Underwriters Laboratories Technical and Safety Standards for electrical systems. And so when it comes to the NEC, the codes, one code that will be followed would be Article 690.9, that pretty much states that the sizes and locations of devices will comply with it. And if there's overcurrent protection devices that will require to prevent overloading of the system. And so when we're talking about the IEEE codes, what will be specified there is code 1547 that will distribute resources that must not cause the voltage at the point of interconnection to deviate more than 5% of the nominal voltage. And when we talk about the UL certifications and safety standards, we want to make sure that we are following 1741 sets standards for inverters, charge controllers, and other PV system components. And so this would help our system stay safe, reliable, and perform if it on time. Thank you. And so when we talk about the effects of the system, obviously there are going to be pros and cons because we are dealing with electricity here and it's going to be high voltages. So when we talk about a pro, we want to think about things. We thought about things such as there being a surplus, such as like there's a possibility of being fed back into the grid because of like class breaks such as like summer vacations, winter vacations, and perhaps there's like Honor said, like Texas, Houston does have hurricane season, so there are times where we're not in classes as often as we will be because of flooding and us not being able to physically get to our campuses. So the system will be able to also provide shed off peak usage with the proposed battery storage that we do have. And so and along with that, we also think about safety and that there will be a disconnect switch in case of emergency to prevent harm to the grid, which is something we don't want to do. And so also so now we go to the cons and we think about it being installed while also being disconnected during maintenance because we don't want to harm the grid or provide the community under any danger. And so other things to think about are the line capacity, voltage regulation, the line congestions, and the network topology, along with the harmonics and the power factor. And so these are the cons, which to who we are proposing our project to can see that our pros can outweigh these as well though. And that is all for me as for distribution system impact. And so I will lead it on to Laura for the construction and development plan.
Okay, hello. I'm going to be doing the construction development plan. Can you switch the slide? Okay, there's three project stages I was concentrated on. The first one is a site overview. We started looking at how big the property is. Approximately it's 175 acres. And also we found that it's not in the flood zone. The next thing is we found the authorities having jurisdiction. We started looking at which counties or what city corresponds to where we had to go permitting. And also we started looking into the zoning ordinances if we have any, which we don't. And that was good for us. Also, the second stage was the permitting and codes. Since this project is based on the city of Houston, they are required a 2015 building codes. And the stage 3 is the construction phase. That's where we were gonna do the site and existing roof conditions. That's where we're also gonna be doing the quoting, subcontracting, getting all the financing done. And we're gonna start the construction phase. And also at the end, we're gonna be having inspections. Next slide. Based on the timeline, we did this timeline where everything's going to be based off. We kind of did like approximately 14 months for approval, for it to be approved from the city and to be constructed and inspected. I kind of did a timeline based on how we were going to do the financial, the takeoffs, the engineering, the inspections, and the materials, and how it's going to be built. And this is kind of an approximately timeline we prepared for y'all. Next slide. For the construction approach, we have 4 steps. The first one is final design and construction documents. The second one is construction procurement for the materials. The third one is the construction of product. And the last one is the completion and commissioning. Next slide. And the proposed strategy for our project is to use the students who are doing the electrical, structural, and mechanical engineering programs to be helping us to do this so they can get real life experience and they can learn and practice and get involved in this project. And I'm gonna hand it
All
off
right,
to Patrick.
and sorry, not to cut off, but we have reached the 15-minute limit mark for the presentation.